After a long time, we finally have real news about NASA's moon lander. And this is not a small update. NASA has released a detailed 50-page report from the Office of Inspector General about the Human Landing System program. This report gives a closer look at what is happening, what progress has been made, and what major challenges are still there. It clearly shows the current situation behind the scenes. And now the big question is, will a moon lander be ready to take humans back to the moon when the time comes? First, let's talk about the issue everyone is discussing. Right now, NASA and SpaceX do not fully agree on manual controls for the lunar lander. NASA has a rule that any spacecraft carrying astronauts must allow the crew to override the system and control the vehicle themselves if needed. This rule comes from NASA's safety standards for human spaceflight. The reason is simple. If the system fails, behaves incorrectly, or tries to land in a dangerous place, astronauts must be able to take control, especially during the final landing phase, which is the most critical part of the mission. The report clearly says that NASA and SpaceX still do not fully agree on whether Starship's landing system meets the requirement for manual control. NASA wants astronauts to have direct control if something goes wrong. But SpaceX may see things differently based on how their system is designed. There is a strong reason why NASA takes this so seriously. During the Apollo missions, astronauts used manual or semi-manual control in every single moon landing. In many cases, the onboard computer selected landing spots that were unsafe, filled with rocks, craters, or steep slopes. Because of that, the astronauts had to take control and guide the spacecraft to a safer location. A famous example is Apollo 11. Neil Armstrong had to manually control the lunar module and move it away from a dangerous area full of large boulders before landing safely. Manual control was also important during emergencies. In the Apollo 13 mission, an oxygen tank exploded, forcing the crew to shut down several systems. The astronauts had to manually manage the spacecraft to survive the situation and avoid further danger. This is not just something from the past. A similar situation happened recently during the first crewed test flight of Boeing's Starliner in 2024. As the spacecraft was getting close to the International Space Station, several thrusters stopped working. At that moment, manual control became critical. The astronauts had to step in to keep the spacecraft stable and guide it safely toward the station. So NASA's concern is based on real experiences, both old and new. But on the other side, SpaceX Starship is very different from any spacecraft used before. It is not like the Apollo lunar module or even the Starliner. Starship is much larger and far more complex. The lunar version of Starship is about 171 feet tall, which is around 52 meters. That is almost the height of a 14-story building. Because of its size, it has a high center of gravity. This means it could become unstable if it lands on uneven ground or a steep surface. To reduce this risk, NASA requires the lander to stay within about 8 degrees of tilt after landing, so astronauts can safely move and exit the vehicle. If we compare this with other landers, the difference becomes even more clear. Blue Origin's Blue Moon lander is much smaller, around 53 feet tall or about 16 meters. Even at that size, it still has strict limits on how much slope it can land on safely. Looking back at the Apollo missions, the lunar module was only about 23 feet tall, which is roughly 7 meters. That is very small compared to Starship. This shows how challenging it is to control such a massive vehicle. Because of this, manually landing something as large as Starship is not simple. Human reaction time may not be fast enough to handle a huge spacecraft using multiple engines during the final seconds before landing. This is likely why SpaceX believes that some parts of the landing process cannot be safely controlled by humans in real time. They may prefer a system that relies more on automation. So now the question becomes important. Should NASA insist on manual control for safety? Or is SpaceX right in saying that full manual control may not work for such a large and complex vehicle? If NASA and SpaceX cannot reach an agreement before the program reaches its critical design review, it could create serious problems. The design of the spacecraft might be finalized with an automated landing system that has little or no manual control. Changing that later would require major redesign work and could delay the entire program. If no solution is found, SpaceX might request a waiver from NASA to relax the manual control requirement. NASA has done something similar before with the SpaceX Dragon spacecraft, used for missions to the space station. In that case, NASA accepted limited manual control because Dragon already had a strong flight history. From cargo missions. However, Starship is different. It does not yet have the same level of proven experience, especially in the conditions astronauts will face during lunar landings. Because of that, NASA may not easily accept reduced manual control. As of late 2025. Neither SpaceX nor Blue Origin has officially asked for such a waiver, but the disagreement about manual control is still not resolved, and it remains a key issue in the program. Manual control is not the only concern mentioned in the report. The lunar lander itself is one of the most risky parts of the entire mission. Because of this, NASA and its partners carefully track all possible dangers that could affect astronaut safety. These risks include problems during landing, failure to launch back from the moon, or issues with docking to another spacecraft in orbit, such as Orion. The goal is to either remove these risks completely or reduce them to a safe level. One important method NASA uses is called human rating. This means designing spacecraft specifically to protect astronauts. A human-rated system must consider human needs, allow interaction and control, and include backup systems in case something goes wrong. NASA understands that space missions will always have risks, but it sets strict limits on how much danger is acceptable when humans are involved. Another major challenge is the landing location itself. The Artemis program plans to land near the Moon's south pole, which is much more difficult than the areas used during Apollo missions. The south pole of the Moon is extremely rough. The surface has steep slopes, large rocks, and deep craters. One of the most well-known is Shackleton Crater, which is about 21 kilometers wide and more than 4 kilometers deep. This makes the landing environment much more dangerous than before. Starship also has a unique design challenge. The crew area is very high above the ground, so astronauts will need to use an elevator to go up and down. This elevator starts about 115 feet, or 35 meters, above the surface, which is very high. If the elevator fails, astronauts would not have an easy way to return to the spacecraft. Because of this, NASA considers the elevator a serious safety risk and is working with SpaceX to create backup solutions. Another concern is the effect of rocket exhaust during landing. When engines fire close to the moon's surface, they can throw dust and rocks into the air. During Apollo missions, this dust made it difficult for astronauts to see clearly. With larger modern landers, this problem could be even worse, possibly damaging equipment or affecting sensors. The final major topic in the report is the program's schedule. The good news is that the human landing system is not facing major cost overruns. However, it is struggling to stay on schedule. Both SpaceX and Blue Origin have faced delays during development, technical challenges, and system integration. Issues are affecting progress and could impact both cost and timeline. The report suggests that SpaceX's lander may not be ready for the planned June 2027 moon landing under Artemis 3. One of the biggest challenges is cryogenic fuel transfer. Starship cannot launch fully fueled, so multiple tanker missions are needed to refill it in space. This involves transferring super-cold fuels like liquid oxygen and methane in microgravity, which is extremely difficult. This type of operation has never been fully demonstrated before, making it a major risk. There are also concerns about launch frequency, as many launches are needed in a short time. Test flight delays and technical issues have added more pressure to the timeline. Because of all this, even small new problems could push the mission further into the future.